Hello and welcome to the channel. Let's learn electronics. In our last video we had started the topic of AC resistance in a diode and we will continue with the same. In my last lecture I had explained this thing in detail. This is a VI characteristics curve and we have to calculate the AC resistance for this point. In case of a DC resistance, this is something very simple. When we have DC input voltage, then this Q point is stagnant, unvarying, as long as there is no alternating input voltage. But the moment we start applying AC voltage, alternating voltage, which is input to the diode, this Q point starts varying up and down according to the variations in this alternating voltage, AC voltage. So how can we calculate the AC resistance for this curve? We just draw a tangent on this Q point and we calculate the delta VD and delta ID, the variations in this voltage, the changes in this voltage and the corresponding changes in the alternating current, output current. So using Ohm's law, this AC resistance can be easily calculated. I have explained all these things in detail in my last lecture, so to understand all that, please go back to the channel and watch the entire video. We will proceed with the next topic in this AC resistance thing. We studied in the last lecture the graphical representation of delta VD over delta ID. We will mathematically calculate everything here, and the standard formula will be obtained by taking the derivative of VD over ID. So how can we calculate this VD over ID? We will first calculate delta ID upon delta VD and then we will take the reciprocal of the answer and we can obtain the equation using this concept. So let's understand this. The basic diode's equation is ID is equal to IS E raised to the power kVD over Tk minus 1. This is also called the Shockley's equation. I have explained this equation in detail in my last lecture. I'm going to pin the link of that video. Please watch that so that you don't get confused with these two equations. In some textbooks you will get this kind of representation for Shockley's equation. In some textbooks you will find this kind of terminology, VD over NVT. So if whenever you are confused with these two equations, just go through that video. Let's proceed ahead. Equation of AC resistance can be calculated by using the simple diode equation. We have ID is equal to IS, this thing. Now let's open the bracket and it will be in this form. IS gets multiplied with exponential term and with 1. Now let's take this IS to the other side. Let's take it from RHS to the other side here, and keep in mind that this is equation number 2 and we are going to use it in the steps ahead. Now let's differentiate equation number 1. We know that the differentiation of a constant is 0 and differentiation of an exponential term is this. So just use this formula and let's differentiate IS, differentiation of e raised to the power kVD over Tk. This is a constant, so it is written here normally. I'm not going to teach you how to differentiate, you must be knowing that. This is equation number 3. Keep a pencil in your hand and calculate it by yourself. Now we are going to use equation number 2 and put the value of equation number 2 over here in this equation number 3. This was equation number 2, this was equation number 3. So we have IS, this part, and this part is just same. Let's just replace it with this ID plus IS and we have put it over here. This way we got equation number 4. IS is almost negligible in comparison to ID, so this part will be discarded just forget it for the time being, and approximately this delta id over delta vd will be k over tk into id. Now let's substitute the values of k over here. This is the ideality factor. Now remember one thing, when we are on the steeper regions of the graph, when we have the graph like this, so for these regions, for the higher regions, when the graph is steeper, this ideality factor is equal to 1, and in that case the answer will simply be 11,600. The value of tk can be calculated as 298 degree. I have explained all these things in my last lecture. So this value of k over tk is 38.93. Let's put the value over here. did over dvd is 38.93 id. Now let's take the reciprocal of the entire thing. We will get rd is equal to dvd over id, and the reciprocal of it, this 1 upon 38.93, it can be calculated as 26 millivolt. Fine. So this RD can simply be calculated if we know the value of diode current ID. We don't need the value of voltage over here. It is fixed 26 millivolt, and in most of the textbooks you are going to find the equation like this. I have just taken a screenshot of one of the textbooks, and you will see that they have given the derivation like this. Some of the students get confused that ma'am, we are not getting how they solved it. I have explained each and every step with the I have taken baby steps to explain the entire derivation. Go through the video again and again. If you are confused, drop your confusions in the comments. So what I explained in my last video, this delta vd over delta id, the graphical representation, there is no need to calculate it graphically. We have a standard mathematical equation for the same. We just need to know the value of id, the diode current. If we know id, then we can calculate the AC resistance using this standard formula. There is no need to go into the characteristics curve details. There is no need to calculate the small minute changes over here in the graph. Just know the value of id and you will calculate rd. But a very important point is that this formula is applicable only for the steeper regions of the graph, for this region of the graph. When we will come on the lower region of the graph, where we have a very gradual increment, just like this, then this formula will not be applicable, because the ideality factor neta will not be equal to 1. It will be equal to 2. So in that case, this formula will not be appropriate. It will not be used. And at this point, I will also tell you that in many competitive exams, this was asked that for a characteristics curve for the lower region of the graph, we have a dynamic resistance or AC resistance. Option 1, it gets decreased, it gets increased, it does not vary. So you have to tick on it gets increased. The dynamic resistance always increases in this part of the region where we have gradual increment, where we have a big slope of the curve. It's not steeper region. So I hope so far you have understood everything about AC resistance. In case you have any confusion, then do connect with us on our email ID, which is this, and stay connected with us. Keep learning with Let's Learn Electronics. Thank you for watching the video.